Hi folks, today we're going to talk about how to set up and run the Shimadzu LC-10 HPLC for the Capsaicin lab specifically, though a lot of these things will also work for other HPLC labs we have. So I'm going to go ahead and show you how this thing works, talk you through the process, and then we'll start collecting some data, and then I'll show you how to process that data also. Alright, so here is our HPLC. This is the Shimadzu LC-10. Right now the machine is off, which is off in the place that you'll find it. And so in order to turn this on, I will typically start from the autosampler and work my way up towards the main controller. The degasser kind of stays on a lot of the time, and it's going to click and buzz and do a lot of fun things as it starts up. A couple things you want to watch are these pumps. They will light up if they're actually pumping. They should not be pumping to start out with. These are on remote control, which is controlled by our main controller here. And eventually, once we start the program, they'll be controlled by this PC. You can log onto this PC, and it should have the programs you need on your own accounts. And we're just kind of waiting for this thing to warm up. Now, one of the things that we're going to want to do is change out our buffers depending on our situation. Our buffers for the Capsaicin lab are 0.5% phosphoric acid on pump A and acetonitrile on pump B. So I'm going to go ahead and set this down, and then I'm going to put the leads of these into the right buffer bottles. And you can tell which one is which because they have little flags on them. For example, this one is flag A. So I'm going to put that into my phosphoric acid solution. Pump B has a little black tag on it. That's going to go into my acetonitrile. And then I also need to change my rinse solvent. Rinse solvent should be the same solvent as your samples are suspended in. So this one says rinse solvent. I'm going to move that into 95% ethanol, which is what our capsaicin samples are resuspended as. And I'll move these bottles around to make the leads fit a little better. And I also like to cover these up so that the solvents don't evaporate too fast. Phosphoric acid's already aqueous, so it doesn't matter that much. Okay? So I got all three of these into the leads. That now means that I'm ready to go on getting the pumps primed. So when you prime a pump, you need to switch the solvent out. You're going to open up this drain, turn it counterclockwise on both pumps, and then you're going to hit purge. Purge is just going to pump the solvent through until it's completely exchanged for the new solvent. I'll do it on both of them, and you can do both simultaneously, and this takes a few minutes. So it'll say purging line. You'll hear the pump start to go. Okay. And that means that the pumps are effectively pumping. You can actually see these lines are starting to pulse as the pumped solvents go through them, and that's a good sign. So once these things are done, then the pumps will be in the right buffer. Now another thing we're going to want to do is go into Lab Solutions, which is our computer control system. It's just admin, no password. Everyone does the same thing. And we're going to want to log onto the HPLC. And this is what's going to allow us to do all the instrument control. It's connecting to the instrument right now. It'll do this beep sound, which you just heard. And as soon as this thing warms up, then we'll be ready to start getting the rest of the columns ready to go. One thing I like to do here is I want to purge and rinse my autosampler so that the rinse lines get changed out for my ethanol. So I'm just going to click Rinse Autosampler. And that's going to make our autosampler syringe pull rinse solution out of that rinse bottle that we just set and rinse itself out so that it's in the right buffer. Okay, just cover that up. This thing, this autosampler here actually pulls out of the autosampler bin in here with this little needle. As you can see it moving around. It's just injecting waste into the waste line and rinsing itself out. So that's the main components. This is our detector, and this here is our column. Our column right now is a C18 column, a 1.8 micron bead volume, 4.8 by 50 millimeter column. Okay, so that's kind of what's going on with these guys. Our pumps are still purging. Okay, it does take a little while. The autosampler's been rinsed. I might also want to purge my autosampler. That's the next little button over here. Let's see, it says rinse autosampler, purge autosampler. Purge will mean I get all the air bubbles out, and it'll give it a especially good wash. Just like we're purging the pumps, let's purge the autosampler. Okay. So that's just going to do its thing. Okay. So we're just waiting for this thing to finish. Pump B has finished its purge. It is no longer pumping. You can see it's not lit up here. And pump A just finished too, so I'm just going to close my drain lines so it does not drain anymore. It goes onto the column. Yeah, so that changes the routing. And then once my autosampler is done with its purge, then I'm going to start to flow over the column. That means we're going to have to set up some settings in the program. So I'm going to cut over there. All right, so this is still the same screen as we were on. It's still purging the autosampler, but we can start looking at some of our parameters. I actually have a preset method file available called Scoville Fast that has all our settings in it, but I'll walk you through what they need to be. Start the to have the LC stop time at 20 minutes, so that means we're going to have about a 22-minute run here, plus all the other stuff. We want 2 different channel detecting, okay? And we're going to start the controller at 0.01 minutes. We're going to have pumps start at 50% B at 1 minute 20 seconds, and then take a 12-minute gradient to get up to 80% of B, which means our acetonitrile is now going way up. That means our solution is becoming less polar. This is because it's becoming less water. And then it's going to go back to B, 50% B really quickly, and then run the rest of the time to kind of flush anything off the column. Okay. So that's our basic time program. It's going to go from 50 to 80% B in 12 minutes, and then back to 50% to wash off. Our pumps are going to run at 0.5 ml a minute, starting at 50% B. Okay. And our detector A is going to detect at 205 nanometers with their deuterium lamp. And our sample racks are good. Our rinse volumes, 500 microliters. Everything looks fine here. And looks good. So that's our program that we can set up, and you can set up a program yourself with those same parameters. And you can pause the video, go back if you want to see all the settings. And it's pretty standard, nothing really not fancy here. Okay. So what I want to do now is I want to start up the instrument, which means that the pumps are going to start flowing. And that means that our column is actually going to start getting flowed over. So I'm just going to go ahead and just close out of this real fast. All right, so I'm going to go ahead and start the instrument up to make sure that it's ready to go. Remember, we're pumping at a 0.5 ml a minute. And so we're starting out at 50% B. That means that our pump A is going to contribute 50% of that 0.5 ml a minute, and pump B is going to contribute half of that. So it's going to each be 0.25 mils per minute. So I'm just going to go ahead and start up the instrument up here with my method file that you can save, of course. And I'm going to go to where I have my program saved here. Scoville Fast is what I called it. And it's going to start up the pumps flowing. So as it's taken on, you can see that the controller is starting up and our pumps have become active. Both our A and B pumps have a light on. And that means that we're flowing solvent over the column. And that means that the column is getting conditioned into the solvent we want to use. Okay? Now, we're going to let this thing run. I would let it go for, I don't know, at least 7 or 8 minutes to make sure that everything is equilibrated and everything's coming together. You also want to pay attention to the pressure here. We can only get up to 100 kilopascals or whatever this unit is, and otherwise it'll automatically cut off for safety so it doesn't blow out the system. So you just want to watch that pressure kind of stabilize, and it should stabilize below 100. That pressure can change based on the solvent mix, but most of the time it should be safely in the 70 to 80 range. Give it a little bit of room so you don't overpressure. Okay. So right now what's happening is that the solvent is coming out of the bottles into the pumps. It's getting mixed here in a mixer, and then it's going through and into the detector, through the column, and then into the waste stream. And actually, if you watch, you can see the little bubbles flowing down our waste line and into our waste streams. from the column itself, which means that we have a good flow of solvent going over those columns. Of course, it's only 0.5 ml a minute, so it's not a whole lot, but it is certainly moving, which is something we want to see. Okay. So that is a good set of news. We are pumping. We can see that something is actually eluting off of the column through the detector. We get a peak here of actually quite a bit of absorbance, and we just want this thing to come back to a baseline and not change, that anything in the lines have been flushed off, that there's nothing really screwing with us. So while I do that, I actually want to set up my batch. And my batch is the instructions for what samples to run, which is kind of the most important thing here. So I like to set up my batch by going to main here and going to batch editor, and then I'll set the vial I want. Now the vial I would like to do is here in the autosampler. These actually go from 0, 1, 2, 3, 4, 5, 6, 7. I want to do sample 6, the bottom corner here. Sample 6. And this little tray can come out, but you want to be sure that you hit those pins in the back and front, and this thing locks in. Otherwise, the needle won't be able to find the right thing. It should be very steady. Pin should be locked here and in the back. So I'm going to do sample 6. So I'm going to go back over here, type in sample 6. I only need to put the sample name in. This is 100 ppm capsaicin. I'll do a 100 ppm test. And then I'll do the same thing here for data file. Okay. And I'll only do a 10 microliter injection. Now I just want to save my batch file. So I'll save that on my desktop. 100 ppm test. So that saves it, and then as soon as this thing comes back to baseline, which it looks like it's doing pretty well, everything's flushed off. This thing only has a column volume of, I don't know, 5 to 7 mils. I'm just going to give it a few minutes here, and then we'll start the acquisition. All right, this has run for a little while. The pressure's holding steady at 75, if you can see that. Our absorbance is not changing. So everything looks ready to go. So I'm just going to go ahead and go into my batch editor. And I'm going to go ahead and queue a batch run with that batch. And that is going to initiate our first run. Okay. So when that starts, you'll start to hear these things come to life. Our autosampler needle is going to go find that vial for us. Rinsing its needle right now to make sure it's nice and clean. Again, that's why we have the rinse solvent there, just to clean out any gunk from the last run. Okay. And then our needle is going to go move over to our sample, just like a vending machine. Okay, it found sample 6 there. Now it's just going to take the needle down into it. Okay. And then the syringe is going to pull a sample for us. Okay. And then it's going to bring it over here and inject it onto the column. And then it's going to go straight through this column into the detector and then out. Right. And so the process here is that this column is very non-polar. Capsaicin is also pretty non-polar, but as we change the composition of the solvent with our pumps, the more non-polar we make it by adding acetonitrile, the less capsaicin is going to want to stick to the very non-polar solvent solid phase here, and it's going to instead come off the column or elute, and we're going to detect it coming through the UV detector. Okay, so you can see the needle is now going to get ready to inject, okay. And it's going to inject 10 microliters as we said, and let's just kind of watch what's going on. Alright, so it just started and it re-zeroed it. It also zeroed out the UV detectors. Okay? And so, just going to let this thing run. Usually our samples will elute around the 4 to 6 minute mark. somewhere in here, so we don't have to wait very long to see our sample coming off. And so I'll spare you guys waiting, and I'll show you guys when it's done. All right, so it looks like we got our 3 elutions. We have our dihydrocapsaicin, our regular capsaicin, and our nor-dihydrocapsaicin in this general region. We have around 6 minutes, around 6.5 minutes, and then around 8.5 minutes for having elutions. Of course, there's lots of other bumps around here. These little guys were things that just didn't stick to the column, flowed off right away. These things did have some retention and stayed on relative to how well they interacted. So these guys came off easiest. This one stayed on a little bit longer, mostly because it has a slightly different amount of carbons in its backbone, give it a little bit more van der Waals. Okay, so as this goes along, it's now coming back to return to the 50% mark around the 13-minute mark, and then it's going to run out. If you don't know which ones are yours, for example, in your extracts, you may have a lot of things all over the place. Using our standards would help us to know which ones are which. So this is a natural extraction of capsaicin. We're always going to get all of the capsaicinoids, right? We could also get things like beta-carotene things. So using these as our reference marks, the elution times, are going to be really important for when we analyze a complex extraction like the pepper extracts. So just pay attention to those 3 marks. And as you do a standard curve with higher and higher concentrations of capsaicin, you should see these growing relatively. So capsaicin should get larger. All 3 of these should get larger relative to how much you made. And then we could essentially figure out what percentage of each of those comprises the sample. So it looks like it's mostly capsaicin, then nor-dihydrocapsaicin, and then maybe a little bit of dihydrocapsaicin in the mix. Okay. Now, one thing I didn't mention earlier was when you set up a batch, back here in batch, when we set up our thing, you might want to go to settings here, and you want to set shutdown. Okay, the shutdown method is just going to be the same as we started. This will automatically shut the instrument off when you're done. So if you're running overnight or something like that, this will automatically stop it for you, so you don't run the bottles dry, you don't run the instrument dry. It'll automatically stop it for you. Otherwise, it's just going to leave the pumps running until somebody physically stops it. So if you're running overnight, you need to come in and do the shutdown process. Okay? So back to acquisition. Just watching this thing, is not much is going to happen. Maybe a few things will wash off, but this is our gold standard for what we want to see on a capsaicin extraction. All right, so the sample is done. Since you see that I did not do this shutdown, my pumps are still running. You can see the green lights here. So I'm going to go ahead and shut this down now. Over here on the top, my acquisition, I just want to hit shutdown. And I just want to set my shutdown with my same protocol, my Scoville fast or whatever I called it. Hit OK. That's going to initiate the shutdown procedure. It's going to turn the pumps off, get them back to where they need to be for the next run. You should see the lights just blink off here. Yep, there they go. So we're shut down here. The lamps are going to cool down as well. At this point, you can shut down once that thing kind of goes away, we can shut off the instrument. So I'm just going to work my way backwards. And the instrument is off. Okay, so that's what you would do if you were done with it and taking down the data in the morning. Now let's look at the actual data that we see. Right, my data automatically goes onto the desktop here, so you can save it somewhere else, but mine goes to the desktop. If you need to find it, you can always go into Lab Solutions, just hit OK, and then go into Post Run, and this will let you look at stuff after the run is over, or you could just go ahead and just click on it from the desktop. Either way works just fine. It's going to do the same thing. So this is our run, our recent run. We have 3 big peaks. We have one around 6, one around 6.5, and one around 7.5. And so we want to analyze those, but we also have this other garbledy-goop stuff around that we should probably at least look at. So if you have clicked on your data and open it, you go up to here to Data Report. And this is going to give you the chromatogram and a peak table that we need to do this. Now, for whatever reason, it wants to leave the peak table really shrunk up, so you can drag it down to get the peaks that you want. We don't care about anything past the 8.617 mark. And really, all you need to do here is copy these numbers down. You can screenshot this, you can write it in your notebook, but what we want is the 6.056 number, which is this peak. Oops. that peak, which is, and we only want the area. We want the 6.497, which is this area, and we want the 8.617 area. If there's other things that you think may be important, then you can write those down too, but if they're not changing with the amount of capsaicin added, then it's not something we really care that much about, okay? So just copy that down. If you have more samples to do, then just you're gonna copy all those data down into a table, kind of like this, and we will then work on processing that in Excel. All right, so what I'm going to do here is I have actually processed that data that we collected earlier from the whole set. So I have a few peaks that I think may be candidates that I have collected from my whole standard curve of capsaicins that I diluted. So the quality of this data is going to depend really on your dilution technique. There's not a lot of scatter in the data once it's through the spectrometer or through the HPLC. And so I have a few of these. I think that the three that we saw clustered earlier, the nordihydro, which is 1 methylene shorter than dihydrocapsaicin, is the earliest to come off. It has fewer methylenes, so it doesn't stick as well. Then capsaicin, which has a double bond in the tail, which means it doesn't stack quite as well. And then finally, dihydrocapsaicin is the most nonpolar, which will be the third to elute. Okay, so what I want to do is I want to plot these integrations. These are my total integration or my total area under the curve versus my ppm that in my prep. Okay, so I'm going to go ahead and just insert a scatter plot here, and I'm going to select my data. My x values are going to be my ppms, and my y values are going to be my integrations. I'll just do the 8 here. So we have a roughly linear data set here for our nordihydrocapsaicin. Not a perfect set of data, of course. It's a 0.94, which is pretty good. But you could always do better by using better dilution techniques. I just kind of roughed this one out really fast. So this will be our nordihydro. And that will be what we use anytime we have a peak around the 4.2 mark. Again, we want to see this trend upward when we do this to make sure that this is actually something that's changing as a function of what's in the sample, not just something that's a background. For example, if I was to show you what's going on with the 3.6 peak, which seems to always come off, I'll do the same thing. I'll add my ppms on my x and my integrations on the y. And I don't really need the 0 because it doesn't make much difference. That doesn't go up with our dilution. So that 3.6 is just a contaminant, or it could be something in the buffer, or who knows what it is, but it isn't what we want. We want to see increasing trends, and so we can use these data to solve nordihydrocapsaicin amounts between 60 and 286,000 integration units. We want to be sure we dilute these to fall into that curve. Now, let's do the same thing for the other two peaks that we know. They should both go up. I'm going to go ahead and add a x for my capsaicin. We have a much larger dynamic range here and equal linearity, I assume, because they're from the same samples. Yep, 96% on the capsaicin because it has a larger response. It goes up to 7 million integration units. So it goes from 0 to 7 million, which is pretty nice. So that's going to be our capsaicin curve. So anything that's around the 4.5 mark when you run this on your own samples will be quantifiable on the capsaicin curve. And then I'll do one more for the dihydrocapsaicin curve. And my dihydro units. Again, one of our, it looks like our 50 ppm one was a defective made, and we could always go back and redo that. But these are all pretty good quality, and still, even though that we have a few outliers in our data, this is our dihydrocapsaicin. So that's we got 3 nice little curves to work with here. We'll move these all up so that we can have all of them side by side. So what this is going to spit out is an integration given a ppm. Of course, if you know the integration, you can always solve for x to find how much is in your sample, which is really what this lab is about, is figuring out how much of these capsaicinoids are in a pepper extract and then using that to score them on the Scoville scale. So that's the basic processing from start to finish of your lab. Each of the runs takes 22 minutes, and so if you're running 7 samples, that means you're going to run for approximately 2 hours for running those samples out. Not too bad. You can easily do that in a lab. If you want to add extra samples from your extractions, go ahead. Easy to do. This instrument is very foolproof as long as you set everything up initially correctly. Then you can always ask me for help if you have problems with that. So I hope that was helpful. Bye, guys.